Assalamualaikum and a very good day to Miss Idura. For the subject DEE20023, I have been assigned to do presentation on selected topic. In this video, I take topic 1 as my presentation, which is Introduction to Semiconductor. First of all, let me introduce myself. I'm Siti Aisyah binti Abdul Rahman from DEP2S3 and my metric number is 13DEP20F1021. Definition of semiconductor. It is a material that has an electrical conductivity that is between that of a conductor and an insulator. Semiconductor device can display a range of useful properties such as passing current more easily in one direction than the other, showing variable resistance and sensitivity to light or heat. Semiconductor also is an atom of a material carries 4 electrovalence. It's also not easy for the atom to lose or gain any electrons such as silicon and germanium. Why is it silicon is more often used than germanium? Silicon has low cost and can be used at high temperature, while germanium high cost and cannot be used in high temperature. Second, silicon is less easily damaged by heat when soldering, but germanium easily damaged by heat. Silicon also can accept more overheat before change to semiconductor, while germanium cannot accept more overheat. Lastly, silicon has a very low leakage current when reverse voltage, while germanium has high leakage current when reverse voltage. Both silicon and germanium are semiconductors and contain 4 electrovalence. P-type and N-type characteristic. Intrinsic semiconductor is a pure semiconductor which have been carefully refined to reduce the impurities to a very low level. No impurities has been added to the semiconductor such as germanium and silicon. Extrinsic semiconductor is a pure semiconductor that have been added impurity into the semiconductor. This process is called doping process, which is a absorption process. There are 2 types of semiconductor material that are subjected to doping process, which are N-type extrinsic and P-type extrinsic. There are 2 categories of impurity, which is trivalent and pentavalent. Trivalent is an element that has 3 electrovalence, such as aluminium, boron, and gallium, while pentavalent is an element that has 5 electrovalence, such as antimony, arsenic, and phosphorus. Doping process is a process of adding impurities to an intrinsic semiconductor to produce an extrinsic semiconductor. It is also to improve the conductivity of the semiconductor. The number of free electrons or holes will increase. These are 2 categories of impurities, which is trivalent and pentavalent. Trivalent produce a P-type semiconductor such as aluminium, boron, and gallium, while pentavalent produce a N-type semiconductor such as antimony, arsenic, and phosphorus. N-type is created by adding pentavalent impurity atoms such as arsenic. This creates an excess of negative electron charge carriers. The electrons are the majority carriers, while holes are the minority carriers in N-type materials. P-type is created by adding trivalent atoms such as indium. The purpose of P-type doping is to create an abundance of holes. A hole behaves as quantity of positive charge. The holes are the majority carriers, while electrons are the minority carriers in P-type materials. The p-n junction is formed when p-type region is joined with the n-type region. This is a basic structure forms a semiconductor diode. The n-type region has many free electron and only a few thermally generated holes, while the p-type region has many holes and only a few thermally generated free electrons. With the information of the p and n-type materials, holes from p-type will diffuse into the n-type and electrons from the n-type will diffuse into the p-type. Combination of electrons and holes at the junction takes place. When equilibrium is reached, no further diffusion of electrons and holes across the junction. So net is what is the depletion layer. When the p region lose holes and become negatively charged, while the n region lose electrons and become positively charged, this creates the depletion region and has a barrier potential. This neutral region, which has no charge carriers, is called the depletion layer. This layer which has no charge carrier is a pure conductor of electricity. The depletion region is a region depleted of any charge carriers. Threshold voltage is a voltage level where the increment of current happens when the applied forward bias voltage reach the barrier voltage. Threshold voltage for diode has two, which is silicon and germanium. There are two types of bias voltage. It is forward bias and reverse bias. For forward bias, the p-type is connected to the positive terminal and the n-type is connected to the negative terminal of a battery. Positive terminal of the battery will push the holes in the p regions towards the junction. Hence, the recombination process occurs and the number of negative ion in the p region near the junction decrease. Negative terminal of the battery will push the free electron in the n region towards the junction and recombine with the positive ion. Hence, the number of positive ions decrease. As a result, the number of uncovered ions is reduced and the width of the depletion layer region will also reduce. Since the barrier potential is now reduced, electrons in n-type will be easily moved to the p region. This is also assisted by the negative terminal, which push the electrons, and positive terminal that pulls the electron. Hence, a heavy majority carriers flow across the junction. The value of current will increase and resistance will decrease. While for reverse bias, the n-type is connected to the positive terminal and the p-type is connected to the negative terminal of the battery. The positive terminal of the battery extracts free electrons from the n region and the negative terminal extracts free holes, which is positive ions, from the p region. The number of uncovered positive ion in the n region and negative ions in the p region will increase. So the width of the depletion layer become larger and the resistance become higher. However, in real p-n junction, there is a small flow of current in the reverse bias mode. This is due to the thermally generated electrons and holes which cross the junction to the battery terminals. As the temperature is high enough, there will be a constant generation of electron-hole pairs, and the current exists is called the reverse saturation current or leakage current. Leakage current is a minority current in material. It exists when the reverse bias voltage is applied to the p-n junction. Electrons in p-type material is pushed by the reverse bias voltage to the region and pass through it. Hence, a very small amount current flow is produced and it is called leakage current. This current can be limited by the external circuit. If this current is not limited, a large power can be dissipated in the junction that may damage the device and cause burnout. Thank you for listening to my presentation.